Hold on, we gotta introduce you. You gotta be formally introduced for the YouTubes. All right. So welcome back. So our next speaker is Mike Conway. He's now at the NIEHS, which is one of the National Institutes of Health. His title today is a GA4GH Data Repository Service for native iRODS.
Okay. Hey guys, I hope you guys are enjoying the conference. I hate I'm missing it with you guys, so I told Terrell to pour one out for me when you guys go into town tonight. But yeah, so what I'm now at NIEHS, which is the National Institute of Environmental Health Science here in North Carolina. It's part of NIH, and we are developing a Data Commons, is what we call it, and sort of working with NIH as they struggle with trying to build an across NIH Data Commons. We're actually now at the sun of the NIH Data Commons and sort of trying to figure out where to go from here. But internally what we're doing is we are developing a commons that is actually more like an institutional repository. So at our campus, we're doing science, and we have multiple core labs doing things like sequencing, mass spec, cryo, EM. So we are actually doing experiments, getting samples, and running all kinds of assays on them, and then handling that data and preserving it. So iRODS is well positioned as a platform for doing this. So not only we're doing the data management, but we are also doing a lot of work on pipelines and workflows, and doing ingest on the other side of instruments and assays, and gathering data and metadata from things like lab information management systems, and preserving that all in our commons. We are using an ISA model, if you guys are familiar. So we have projects and studies, and we're trying to arrange and link our data together with the scientific questions, the hypotheses, and so forth, so that we can start doing a lot of data discovery and smart searching based on things like genes of interest, proteins, pathways, and so forth. So we saw this with the NIH Commons effort, this notion of trying to bridge together the different parts of NIH and external collaborators and start working on data that is distributed and also data that is moving rapidly to the cloud. And so what we want to be able to do is access data in disparate systems. We want to be able to do computation on that data in the best place possible, and we want to start using standard workflow languages such that our pipelines and our data are portable across all these different data platforms. So GA4GH, I'm sure you guys are familiar with it. It's a global alliance for genomic health, and we've become involved now with their cloud work stream and trying to align our efforts with sort of larger efforts. And so institutes like Broad, platforms like Google and Amazon are all participating in this GA4GH effort. And you can see here there are standards in the cloud work stream at the bottom for data access. And then for the layer above the task execution service is the ability to run tasks on multiple endpoints, if you will, and then the notion of a workflow execution engine that can execute these tasks that are running on different platforms, Google, locally, Amazon, and so forth. And then the notion of registering standard tools and workflows. So all these stacks work together to have portable data and portable workflow and task execution. Now these standards are sort of in a formative state, but again, it seems pretty smart to try to align our efforts with the larger world as we try to build this commons in terms of risk reduction, in terms of having access to libraries other people are building. It seems like a pretty sound strategy to kind of keep our hands in this arena. So what we've done here now is we've addressed this bottom stack which is this data repository service. It used to be called data object service, but essentially it's a way to access data from tasks and workflows across different platforms and clouds and so forth. So the data repository service is an API definition. It's an interface so that data consumers, including these workflows, can access that data no matter where it's stored or how it's managed. And that actually sounds very similar to the goals of iRODS and why we are and you folks are using iRODS. So what we want to try to do is bring iRODS into this sort of stack in different places. Okay, so in order to further that, we now have, I would call it alpha. There's still some cleanup to do, but there is a GA4GH implementation that sits on top of native iRODS collections. So this is really nice because the barrier to entry is very low. And we'll talk about how this works, but essentially you can designate iRODS collections in place as a data bundle, and we have some little services that will do some metadata decoration and so forth so that you can present your iRODS collection as a bundle and just run a little sugar on top of it and access your data collections now from workflow tools like CWL and WDL. This is the goal. And again, the emphasis here is on a low barrier to entry. There's nothing special about the setup. The service is a stateless Docker image and it's horizontally scalable. So, I mean, we will see, the proof will be in the pudding, but we are starting to engage with GA4GH. I actually sent them this presentation and hopefully we'll present this to the cloud work stream sometime in the very near future. So here's just a little code snippet. There is a service that we've built that manages all the CRUD for data bundles. So essentially you get an instance of the service and you say, take this collection, make it a data bundle, and it does all the work for you. And what that involves, I'll pop over here to a terminal so you guys can see. When I run the service, and this is just the product of some unit tests. So if I do an ILS, I'm looking at this, and tell me if you guys can see this okay. I'm looking at just a iRODS collection called test create data bundle. And after I run the service, very simply, and I'll look at my command history, I'm just going to look at the metadata. So what you'll see here is after running the service, I have a GUID that's been generated and a marker ABU that says this is the data bundle. And then I also have a checksum ABU. And so this is a checksum of checksums for all the constituent data objects in that bundle. And this is all just part of the specification. You'll also see, as a product of running the service that marks the data bundle, if I look here, I'm now down in the collection, so this is a nested collection, but what happens is the service will represent, in this case, a file in that data bundle is marked as a data object. It has its own GUID, and so you can have a nested collection, but it is presented as a flat data bundle from the GA4GH Data Repository Service perspective. And we'll see that in just a second. Okay, so if we go back to the presentation, and here's just a slide reflecting that the child objects are now data objects with GUIDs. Okay, so the DRS is a Swagger-based system, and it's actually pretty lean the way they have it. And what we'll do is I'll actually just go through, since it's pretty compact, the features of the data repository service. So first you have an endpoint that is giving you service info. So if I execute this, you'll see there's some things about the version of the service and titles and descriptions, so you can describe your data source to end users. The notion of bundles then, so every bundle is accessed by its GUID, and in this case I've plugged in a bundle ID, and if I run the operation here, And you can see here the endpoint is you're going to the bundles resource and asking for a bundle by its GUID. And if we look at the response body, and I'll try to make this a little bit bigger. So it has a GUID, it has a name, in which case this is the iRODS collection. This is your checksum of checksums here. There is a notion of description, which right now is hard-coded, but we want to add some facilities that you can decorate this with some more metadata. And then the bundle lists the contents, the data objects that are inside the bundle, and it provides a URI to each object in the bundle by its GUID. And there's some other data here. They had lots of facilities for metadata description, which they had yanked at the moment, and I think gone with a pared down depiction of the bundle and its objects, but I do expect to see a return also of descriptions of the metadata for these objects and the collections as part of these responses. Just so you know that metadata was in there, they kind of took it out, but I expect that it will be back. So you can see the bundle is just these list of objects by GUID. Okay. So then to access an individual object, you know, the analogy or the example I would use would be if this was a run on NovaSeq, you might have data objects that are FASTQ files. You might have objects that are QC images or reports or so forth from the sequencing or the pipeline that ran the sequencing all in a bundle. So if I wanted to access, for example, a FASTQ file in a workflow, here you can see the request here is to objects given the GUID of the object, and the response is down here. Again, very similar to the data bundle. You have a file and sort of the iRODS catalog information, its checksum. And this is really interesting. So then you have a set of access methods. And this is set up so that you could have a method to get it from an S3 bucket, from a file, using HTTPS or SFTP. I've chosen two access methods for this first iteration, and the first method is a file using the iRODS URI. So there actually is a registered iRODS URI format in this case. This file with its absolute path, including the server coordinates that you could use to access that file, and we're calling that access ID iRODS. The second access method we have here is type HTTPS. And you'll notice that this access method does not provide a URL in this response, but you get an access ID. So this is interesting in the sense that we can use this to generate tokens to access the file. So the way this works is if you have an access method with an ID but no URI, then you call this third method to get the URL with which to access the data. So what happens is here I'm going to call with a data objects GUID, and then with an access ID, I'll invoke this method. Okay, and you'll see that now I do have a URL that I can access. And you'll notice that it's providing a header here with a bearer token. Now, I'm not exactly sure if this is the right place to put this, but what happens here is when you call the HTTPS method with that iRODS REST access, what you get is the system will generate a read-only ticket for that file in iRODS and then provide that back with this URL so that you could actually give this URL and token to a workflow, and it could, without having iRODS credentials, access, for example, a FASTQ file from a CWL workflow direct to iRODS. Okay, and that's basically it. Okay, so it's a very simple API, and it kind of puts us in the game of starting to work with some of these distributed workflow systems that GA4GH is cooking up, along with Google and Broad and other places. Things like 7 Bridges. Okay, back to the presentation. And hopefully you guys are hearing okay. So it's a Swagger API, and this was just going through and highlighting some of the aspects of the API, so I don't have to repeat that. So just in terms of next steps, there are unit tests for this, but some integration testing and packaging is still to do. There is a Docker image that's very easy to build. We want to validate this with GA4GH, so we've reached out to their cloud workstream folks to make sure we are understanding exactly how the API is intended to be implemented, but also to look at compatibility testing, test kits, and so forth to do that validation. We did want to add the ability to have a standard way to attach descriptions to the bundles and the data objects, and then we'll be at a beta release. The HTTPS download endpoint, we left out of this implementation. We may put it in there, but I was more of the feeling that this would be a really good candidate for revising the REST API and start with a standalone download service that can implement tickets and provide the endpoints outside of the, so I didn't want to mix the GA4GH code with the download code. So just imagine a set of Docker images that are the GA4GH DOS API, and then another set of Docker images that are sort of a kernel of a new REST API that are just focused in the first initial release with just the file download. Okay, so a couple other things I think would be useful would be a command line tool set to do the CRUD on the data bundles. There was in the previous DOS API the ability to create a data bundle in place, but I don't think that's really necessarily, it doesn't necessarily go with the API. I would rather see that as a set of command line tools or rule sets. Okay, another thing would be policy sets to enforce immutability, if we wish, on data sets that have been marked as GA4GH data bundles. It's not really a part of the spec, but if you update, you want to manage the checksums and so forth, or add new data objects to a bundle. Another thing would be, the HTTPS access method is just using HTTP download. I think a quick download utility that can honor iRODS URIs just as a small little piece, using parallel transfer or being able to use the pluggable transfer that is being cooked up by the iRODS folks, would also be a nice sort of addendum to this toolkit. Something that you could use inside of a workflow or a Docker image if you had a large file that you wanted to use in your workflow, and that could also be integrated with tickets to make it easy to pass tokens into running workflows without having to provision iRODS accounts into a running workflow. Okay, what iRODS needs. So this is where we get to tell Jason and Terrell what to do. iRODS really needs to focus not on the parallel transfer or multi-part transfer, but on the raw I/O performance of streaming I/O. This is doing an open, doing multiple reads with buffering, and then doing a close. So focus on the I/O performance of the streaming, especially when you're piping it through HTTPS. Everybody has that problem. I didn't point out, but we are doing MIME type detection as it's part of the API. Now we do that through Tika, and we have it abstracted out. But a standard way of computing the MIME type and storing it for subsequent query, the same way that you can compute a checksum, but you don't have to recompute it if you're just asking for the checksum. This would be really nice to get into the core of iRODS. We do have facilities for we do have some facility for doing this that we want exposed through REST and through things like metalinks, but standardize that across those platforms. Everybody does this. Maybe a way to do this would be iCommand support for downloading based on just an iRODS //URI. Make that a first-class citizen. because we also want to work with GA4GH to put these iRODS semantics into the mix in their service. So make iRODS an access method sort of in their enumerated access methods that right now include things like Globus and S3. So there should be an iRODS access method with some support for either the HTTPS download or for high performance transfer where indicated. And that might actually be a nice win for the iRODS community, is to put high speed data transfer into the operation of something like DRS. And they are looking for people to sort of collaborate with and create reference implementations. So that might be something of an opportunity to sort of bridge into another open source consortium. Okay. Another thing would be a standard notion of a file description. Is it a comment? Is it a standard ADU? Again, this has other utility outside of the DRS. And then again, this notion of an easy way to mark a collection as immutable, and whether that's just being done through setting iRODS permissions, if you will, to read only, or whether there's something deeper that needs to be done, I'm not quite sure. So yeah, so I expect we'll be presenting this to GA4GH sometime soon, and then a beta coming down the pike, and that's it. I'm done.
All right, Mike, we have a microphone in a pillow that we throw around the room. It's very soft. Does anyone want to catch the pillow and ask Mike a question? I think he can hear you. All right, we have one. Can you see us walking up the left? Yeah.
Hey, can you hear me?
Hey, how's it going?
Fine. So the API stability itself, not the code you wrote, I get that's newish, but the API itself, how stable can that be considered, or how far down the road of an API version 1 that's going to stay stable for the foreseeable time to come? How far is that within this GA4GH endeavor?
I would consider it at the moment unstable, because when I started working on this, it was the data object service, and now it's the data repository service. So I've had to sort of change horses in midstream. So I would say I would treat the standard itself as beta. It seems like it's coalescing, but honestly, we'll need to have more of a sense of this as we start moving up the stack and trying to access this, as we start working more with CWL and WDL and some of the GA4GH workflow standards. I will tell you that NIH is all about CWL, and it's become like the 800-pound gorilla in the room. I think that's a mixed metaphor, but so I think that I would treat it as beta and not super stable, but I think that the way that they're going with it, it is very easy. It will be very easy to adopt the API, and we've segmented the services underneath, so it's pretty easy to absorb if they rearrange some of the model that they're using.
Okay, so once that is stable, we should expect any client that talks to that API to be able to talk to Google, iRODS, and anything else that implements that.
That's correct. I mean, one of the nice things too is, and the way I see it, if you can talk to iRODS, you can talk to all of those things. And we're very interested, and I will say this, is that there's a real market here, or real potential for iRODS. We have this issue where we have lots of data that will not go to the cloud. Data that's coming right off of a sequencer, I can't see pushing that right up into an Amazon bucket. But usually the product of pipelines, creating BAMs or VCFs or something, could get pushed up into the cloud for further analysis. So there's this real notion of iRODS sitting sort of as the mediator at the border between the local storage resources and the cloud resources, and acting as sort of the gateway between the two, is a really nice place, I think, and that's why we continue to be interested in it. But what we're trying to do here is start trying to develop techniques and approaches that we can prove on the local that sort of future-proof us as stuff does inexorably move out to the cloud, if that's a good answer.
Yeah, good. We have a couple more minutes, perhaps. Anybody? Nope. I think we're done. All right, Mike,
Okay.
thank you so much.
Thanks. You guys have fun.